So in this video, let us discuss about the real and apparent depth. Suppose we have a beaker which is filled with some liquid, let's say water. Let's take water for convenience. The water is filled to a height, let's say T, and we just placed an object, a point-sized object O, at the bottom of the beaker. Let me draw a normal through the surface to the point object O. And let's take this point as some A. Let us consider another point B, and a ray from the O reaches the B like this. This is a straight line. Okay. Now let me draw a normal in here. Let's call this as N dash. Let's take this as M. Okay. Now clearly this is water and this is air. So when compared to water, air is rarer. So when light travels from denser to rarer medium, it bends away from the normal like this. Okay, it is supposed to move like this, but when it travels from denser to rarer medium, it bends away from the normal. That is according to the property of refraction. Now, let this angle be the angle of incidence, that is the angle between the incident ray and the normal, and this angle will be the angle of refraction, that is the angle between the refracted ray and the normal. When you look at these two lines, they are parallel, both are normals, so they are parallel. So if this is I, this also will be I. Now, when I look from here, I see this object O, this point-sized object O, raised through this height. So this is call this point as O dash, which will be the apparent position of the object. See, this is the real position, but when I view from here, I clearly can observe that this object is raised. Okay, so let's call this distance, that is the distance of O dash from the surface, let's call that as T prime or T dash. Okay, so T dash represents the apparent depth, and T represents the real depth. Clear? We need to find the relationship between T dash and T. For that, let me consider these two triangles, that is AO dash B and AOB. Consider triangle AO dash B and triangle AOB. Now, when you look at here, angle AO dash B will be R itself, since these two lines are parallel and these two form the corresponding angles. Okay, these two forms the alternate interior angles. Both the corresponding angles are equal. Also, the alternate interior angles formed when two parallel lines are cut by a transversal also are equal. Now, if I take the value from triangle, let's say AOB, we have sin I, sine of angle of incidence will be, sin is equal to, sin I will be opposite side, which is AB divided by the hypotenuse. Hypotenuse here is OB. Similarly, sine of angle R, sin R will be opposite AB divided by O dash B. Okay. Now, from Snell's law, we have sin I divided by sin R is equal to a constant, and that constant will be the refractive index. See, there is a condition. The light is traveling from water to air, that is from this medium to this one. So we have to consider refractive index of air with respect to water. Okay, since the medium is, the light is traveling from water to air. So we have to consider the second medium with respect to first medium. Okay. Now, when I apply these two values in here, so sin I will be AB divided by OB divided by sin R is AB divided by O dash B, which is equal to, I can rewrite this as refractive index of water with respect to air. That is in accordance with, we have by the property of refractive index, mu21 is the reciprocal of mu12. Clear? Now, when you look here, that is refractive index of water with respect to air. This is actually the absolute refractive index of water. Anything which is refractive index with respect to air as air or vacuum is considered to be absolute refractive index. So I can simply write it as mu itself. Now, simplifying this, we have AB by OB into, I can take the reciprocal and multiply, O dash B by AB will be 1 by, instead of this, I can write mu, since it is the absolute refractive index. Cancel this, so that O dash B by OB will be 1 by mu. Call this as equation number 1. Okay, now listen this part very carefully. See, both these rays, that is OA and OB, before that, if I observe from here, when my eyes are here, when my eye is here, I cannot see the difference between O dash and O. I cannot see the normal shift or the height through which the object is raised. So when I look from here only, I can see the difference. So both these rays, that is OA and OB, should move through my pupil. Then only I can observe this separation, that is OO dash. That is, if I draw my eyes, both these rays, that is OA and OB, should pass through my pupil. Pupil is that region at the center of your iris, which is very small. So when these two rays pass through my pupil, I can observe this shift. Okay, this real and apparent depth. This is the pupil. Okay, which means AB is very small. AB can be approximated to 0. Which means when this is very small, we can write OA. OA is approximately equal to OB. Similarly, O dash or O dash A approximately equal to, that is O dash A approximately equal to O dash B. Clear? And I can replace these two, O dash B with O dash A and OB with OA. So this equation 1 can be rewritten as O dash A by OA equal to 1 by mu. But we know O dash A is the value T dash, which is the apparent depth. So apparent depth, that is T dash, by this OA is the real depth. Real depth, that is T, will be 1 by mu. Clear? Or the apparent depth T dash is equal to real depth T divided by refractive index. Clear? Also, one more point, T dash is inversely proportional to refractive index. So with increase in the refractive index, the apparent depth reduces. Clear? So this is the relationship between real and apparent depth. Now we must find the normal shift. The term normal shift. Normal shift is actually this raised height, that is OO dash. How will you find OO dash? Which will be OA minus O dash A. So that will be T minus T dash. T is the real depth, minus T dash, we already found that as T by mu. So I can take the T out. So 1 by 1 minus mu. So the normal shift is usually represented by delta T. So delta T is actually T into real depth into, I can cross multiply this, mu minus 1 by mu. Clear? So this is the expression for the normal shift. Clear?